Today, I'm doing a presentation for you on what's happening with moving goods and services in the city of Vancouver. And what I want to do is demonstrate to everybody that this technology is, people talk about it being far away, 5 years away, 10 years away, but this is state of the art. This is what's happening today. And through this demonstration, I'd like to pass along some learnings that we found while we were going through. So first, this is William Clay Ford, the chairman of Ford, and it's pretty clear what he has to say, and that the mobility model that we have today simply does not work and will not work tomorrow. And everybody's talking about smart cars, but not many people are talking about smart roads, smart infrastructure, smart hospitals, and all of these systems need to be connected to make a connected community. So what I want to demonstrate today is a couple things. First of all, that your data needs to be architected so that your city or company can be smart. This is the way of connecting all those pieces of data that you have that are best of breed or that are existing, but you need to create an API to connect all of these together. And you also have to realize that when you start connecting all of this data together, it actually turns into a profit center, not a cost center. So autonomous vehicles, people think is a transportation issue, but it's not. It affects everything. This is a picture of suburbia, and in suburbia, you can see the area of parking and parking lots. And you can imagine if this could be wider roads or this can be new buildings, how that changes everything. And people talk about vehicle to vehicle, but it's vehicle to pedestrian, it's vehicle to home, it's vehicle to grid, it's vehicle to infrastructure. And also, let's not forget, it's infrastructure to everything. To make this work, it's just not the vehicle, it's all the other systems. So that being said, first, there's an architecture that needs to be created. And the old method of designing it was one big data lake, which is a great honeypot for hackers, and one big piece of software, which really does not work. The system needs to be architected where this could be SAP or Oracle, this could be Geotab telematics, this could be city taxation, this can be many different software systems, and through an API or a data creek, we move up to a level where we do the business logic through microservices. Or think about this as, an Apple phone where you have the OS system that's secure and controls everything. And Inovex does OHIP records. We do medical, so we understand how you design ethics and security first. And then you start putting apps in place. And these apps will pull information from traffic and from weather. And that gives you a totally different picture. So you have all these microservices, which you can turn off, turn on, remove, add on to, and the whole system stays live. Then to whoever the user is, you make a custom interface with what is it that they need to do their job quickly and well. So this is the data architecture that needs to happen in a city, even before you start talking about autonomous vehicles. Once you start connecting these pieces of data, you start getting enough data where you can start predicting. And if you can start predicting where traffic is, where things happen in your city, you can start preventing those things from happening. And this is really important because you're moving from hindsight to foresight. Once you can prevent that from happening, then you need to pivot the organization in real time so that everybody starts moving forward. And pace is also, we found, very important. There's a lot of times we work with companies or municipalities where one group, whether that's IT or business development, they move quickly and the rest of the city stays behind. And you have to empower the entire organization to see these changes. If if data comes to the person providing data back to them, then suddenly they provide you good data. And this is important to remember, these 4 pillars. So let's talk about what's happening in Vancouver, where we co-developed this over the last 3 to 4 years. And this is a system that can go autonomous now for street cleaning and things like that. But it's a system that was developed by both of us so that we can do a lot of different things. And I'm going to show you screenshots of this. But the value that's created is the visibility into real-time locations and data of everything that's going on, easy visualization of the problems, because usually the problem happens between 2 pieces of software, whether that's SAP and telematics. It happens between them, not in them. So you have to have a way of connecting these. We have to digitize the processes so that more and more APIs can be added, and that you have mobile devices involved too. So you start thinking differently. And that's really a key here, is to create a culture of collaboration between the city workers, the unions, the software vendors. Everybody needs to collaborate for all of this to work. So these are 2 screenshots of what's happening yesterday in Vancouver. And you can see every single one of their trucks and where they are. And every roughly under 2 minutes, this is updated. So everybody knows where everybody is. They're broken up into routes in the morning as to where they're going to drive. They're broken up into beats, small teams, so they can work together. So in case one team finishes up before another team, there's communication between the vehicles and they can go help. So everybody comes home at the same time. They can look at fuel. They can look, if this were to be electric vehicles, where they need to stop to maybe have lunch and charge. This is all interconnected. So we look at the time of year, the weather, Google traffic, all of these to route these trucks. And these trucks do not make left-hand turns. These trucks have been working very efficiently. And the number that the city of Vancouver uses, at least in this sanitation, is they save approximately $60 per day per truck. So that's approximately $2 million for the city of Vancouver. So this is making the money. Then you can go deeper into one of the vehicles if you wanted to. And from one of the vehicles, you actually can see the route that it's doing, that it is completed 383 of its 1,000 pickups. So it starts to let someone know the information deeper if they need to go deeper. This is another picture of what's happening in the city when the trucks are driving around. And some people will say, well, this is strange because Process Legend says you're more than 100% complete. But what we do is look historically as to the garbage pickup. And if the garbage pickup seems to be greater and greater and greater, that's a sign that the area is densifying, that maybe there needs to be a different tax base, maybe something else needs to happen. And this is how integrated the system is becoming to pull taxation information, mapping information, garbage truck information, everything together so people can make decisions. A supervisor can then look in even more detail if they wanted to at each vehicle. They can see what percentage of the routes are completed, what's happening with the trucks. They can also go into work review of each single truck to see when did it start, how's it doing. And you can see we're even providing machine learning or AI predicting what's happening, where they are. So this predictive matter is very good when a new traffic accident happens, when a tree falls and the routes have to change, when a truck malfunctions and a new truck has to come into it. You need this live system to correct everything. And then you can see that you can drill down into a certain vehicle and get even more information as to what's happening with this vehicle, that it's in green bin and, it's going to do these 4 trips today. What we also did with the city of Vancouver is we created a mobile app that sits in an Android tablet within the truck, but also can sit within a handheld device. And the trucks that do waste management in Vancouver have cameras that look into, for instance, the bin when it's being emptied to make sure there's no propane tank or something that shouldn't be there. And if you think of it, the city truck, the garbage sanitation truck, drives pretty well the same route each week or two. And because it's doing that, now the driver can become the eyes of the city. He can tap here on his tablet when the vehicle is stopped, and he can put in remarks to say, fence is damaged, new graffiti, there's a pothole, a tree's down, there's a vacant house. All of this information now can be put together and sent to the right areas of the city so that people can then act upon it. What you're seeing on this screen here, these little X's, and the city of Vancouver is now moving to RFID garbage cans, just like Burnaby. So they will know whose garbage can they're picking up, how heavy it is. It will give them even more information. But this is actually driver knowledge. So the driver can click here on this X and put in something to the effect of, you need to turn the truck around and back down this alley, because if you go forward, there's no way of turning around and getting back out. So this becomes a database for new drivers. Or they can put an X in and say, something's wrong with the city's mapping. Something is different now, something has changed. So it becomes a knowledge base. And in connecting all the different parts of the city, we also connected to the city of Vancouver's 411 call system. So that call now can be routed right to the truck. So as long as the truck is still, the waste management person can click, and if that complaint is that a garbage can was missed, they are maybe close enough to pick it up. They already went by that street an hour ago and that garbage can wasn't out. But they can answer all of these things on the fly, and they have gone from almost 200 missed calls a day or missed garbage cans a day to just a few per day now. So this is making, the municipality, the people happier. And please remember, if you're thinking of a system like this, think beyond garbage trucks. This can be snow removal. This can be delivery of food. This can be all kinds of things. We're just showing you an example of what's happening today. Through this system too, through this button, one garbage truck person can communicate to another one in case they're finished and they can go help someone. By the time they get there, the routes have been split up into what's called beats, and they can all do their job together and be done quicker. We also, for the city of Vancouver, because this is now a digital model, we even simulated with the unions putting in an extra shift of garbage trucks. And we showed that the extra shift of garbage trucks with hiring people will actually save the city $1 million a year. So you now have a digital model where you can try different scenarios to see what would happen. This is a live picture. I'm not sure how well it's coming out for you, but you can now see where idling is happening in Vancouver. So when the system or our manager can see where the idling is, we can reroute the trucks to make sure that they're not going down main streets that have traffic and vehicles are idling. During rush hour or during certain other periods, we can redo the routes to save them fuel. And they do save about $400,000 a year in fuel. We also provide them with filters so that they can take that moving model and then filter out certain locations, certain parts of the city, certain parks, and they can start to analyze to understand what's happening in the city with traffic management or other things that's creating these problems. And of course, we can dashboard it differently to different people in the city, because maybe somebody wants to see fuel efficiency. And for many municipalities across Ontario and then into BC, we also do things like carbon capture. So we look at the baseline and we let the city know how much they're saving in carbon according to the Paris Peace Accord. So you can see, climate accord, excuse me. You can see if you provide the right dashboard to the right person, suddenly their job becomes much easier. We even, because there are geotab devices in their trucks, we can even monitor the different trucks. And as you can see, this is the range of tire pressure that should be in the trucks. And you can see here's one that's correct, but you can see 3 others that are not correct. So for health and safety, this becomes a proactive health and safety issue where we can pull off that truck and make sure that tire is correct before it's loaded up with even more weight and could cause an accident. And then, you create simple dashboards like you would in a car that all you really need to quickly look down is see your speedometer and your fuel. But then if you want to look deeper, there are other buttons you can go down and get more and more and more data. But each person in the city has just the dashboard that they require. And the person that's looking at fuel can monitor fuel by month, per day, by vehicle. You can also start doing analytics, so you can watch where people called in on your 311 calls to see where they dropped off or where they said garbage was missed, day by day by day. And you can see some days are better than worse. And even sometimes the routes are beyond where they're picking up today. So people call from the wrong areas. And you can start taking this insight to make your citizens happier and, and obviously save money. Or you can make the citizens be able to see this map so that they can see where garbage pickups have been missed. They can see where garbage trucks are today, or where are the snow plows and what have they completed and when are they coming. This becomes a connected community, and a connected community is a smart community. This is another routing visualization that we did for the city of Vancouver, where down here is where the trucking station is, where they dump the garbage. But you can see as they're doing the route, the heavier the truck gets, the worse the mileage is. So with this type of knowledge, why not reverse what they're doing and start the truck at the most distant part where the truck will get better mileage. And as it gets heavier, it gets closer to the transfer station. These are all, new live insights that we do. And once we do it, we now have predicted it, so we can move to pivoting, where there's more real-time information, explain to everybody what we've done, because maybe there's other parts of the city that can take advantage of things like this. So I'm going to come back to good old William Clay Ford here and kind of recap or redo what we were talking about today before we get into some questions. And truly, cities are, challenged on this autonomous vehicles, autonomous movement of goods, what will happen. And I think the system, the knowledge here that we're trying to show is the data all has to be connected before this will work. You're not just going to buy an autonomous street cleaner and suddenly it's going to work in the city. What we need to do is understand how the data is going to come to this vehicle, what data the vehicle is going to give off, what data is missing, how do we secure it, how do we make sure it connects to everything else around it. And that's when you start getting a connected community where you actually, design the data architecture first. And that the city of Vancouver has now taken a stance that it will not purchase any software from any vendor that doesn't have a robust and good API. API allows the software to talk to each other, to exchange data, to give information. It's becoming an API-centric software city. So with that, it can become greener, it can become more efficient, it can remove modules, add modules quicker, and have software like Inovex's that is overviewing everything and providing knowledge from the shared services. And I think the last point that we learned in our journey going down this city of Vancouver and with other cities is really, it's not a canned solution. Every city is quite unique. The unique part is cities help each other. So if you call Vancouver, they will take you down their journey and tell you where they're at. But it is this collaboration that needs to happen. It is all parts of the city talking together with the private sector, with the unions, with the software. And this collaboration starts making a connected community, which then in turn will make a smart city. So I'm going to open up the question area, if I may. And just looking at the questions now, there's a question here that what are some of the measures taken to deliver redundancy and ensure business continuity and downtimes? Well, just like the previous speaker, Eric, you always want to get your information from more than one device if possible, more than one sensor if possible. So the redundancy is to get the information from multiple sensors, just like a car. Don't just believe the camera, don't just believe the LiDAR. You want to have different systems telling you that information. And once you have the different systems telling you that information, then you can start building in redundancy because your failures are not at one node. And the redundancy then becomes, difficult to penetrate because you've also made a digital model. So you can test things before you actually make it go live. Next question here, does Inovex solution include AVL or does it integrate with existing AVL solutions? How is the data shared in real time and the conductivity method at the vehicle? So the conductivity method at the vehicle today, when the vehicle is a waste management truck, is through the 3G, 4G network that is part of the GeoTab Connect system so that we can communicate through that system data in and out. The information coming from the garbage truck isn't exactly real time. It's about 2 minutes delayed. And with that 2 minutes delay, it's pretty good. And we did not start with a live system that provides all this information in real time. Suddenly, we work with history. We look at all the data, we work with history, we see when accidents happened, for instance, what were the involvements, what happened with the other data when this incident happened, and from that you can start predicting. So we always work from the past to start looking at the future. What is the process in developing these multiple dashboards? Is this all a custom solution for Vancouver? The answer is yes. It is custom for each person because what we've learned with dealing with large companies is really it's empathy at the node. It's talking to a nurse to understand what a nurse does and what she needs to see on a dashboard because we do healthcare systems. It's talking to the sanitation driver to see what is it that they really want to see. And with this type of custom dashboards, you develop it once. It may take you a couple days to pull in all the data streams, but as you develop it once, it then becomes automatic. It refreshes unless, there's a problem, and then you go through a normal, ticketing item if there's a problem. But usually when it's designed once, designed well with empathy, so the data comes also back to the driver, things go really well. Next question is all the data from the trucks, not the infrastructure, or both? It's actually coming from both. So there is traffic information, the lighting information, the traffic signals. There is information from the weigh stations. How much did the truck weigh when it dumped its load versus how much did we predict it would weigh, even though there is a small sensor in the arm that lifts the garbage into the truck. So we are doing both systems, infrastructure, I to X, plus V to X. Is this integrated with My Geotab? Yes, this is actually on the My Geotab page. And interesting to note that in 2016, Geotab actually bought its global positioning plus dashboard presentation from Inovex. So we're actually closely linked. We don't have to work with Geotab. In this particular case for the city of Vancouver, we did, but they get to see it through their My Geotab tab. And we just overlay all kinds of extra information that gives them wisdom. Next question is regarding garbage collection. Did you face issues with security breaches and how did you resolve? Because we designed in ethics and security at the beginning of the design, this is, you always start in quotes at the end and then design the workflow. We put in the same type of security and ethics systems that we use when we do healthcare data in hospitals. So it was designed at the beginning. We constantly get audited because that's part of the City of Vancouver system, but we have not had a failure or a corrective action yet from their security audits. How does your system support interoperability from separate fleets or different fleets serving the same area? Well, again, if the fleets are all using Geotab, that's quite easy to do. If the systems are using different GPS systems, we deal with pretty well all of them. So we can integrate them and put them on one dashboard. So yes, we can deal with different systems, different camera manufacturers, different sensor manufacturers. We do not make the hardware. We just deal with the data. So the last question, I believe, is that we'd like to hear my thoughts and readiness of other cities and opinion on the technologies and what are the barriers and what would we recommend. So we see that City of Vancouver is ahead of the curve. They truly have a vision and people that are creative. And there are similar cities like the City of Vancouver that actually the City of Vancouver is helping teach so that they can not make the same mistakes and learn from the methodology that the City of Vancouver took. But we also see that there are cities that think that open data is it and that's all that's going to happen. And truly, it's the innovation that has to happen. It's creating that culture from whatever it is and working together. Because even in a smaller city, if there are trucks from a private company that have, for instance, Geotab sensors, why can't that information be shared by that private company to the smaller municipality? This is all collaboration. This is all working together. So it's, I think, having an open mind to what can happen. And I'll give one quick, item that happened in Oakville, where I live, where the mayor wanted to put in sensors to see whether it's raining so that he wouldn't have to water the parks and could cancel soccer games. Where all we needed to do is put a geofence around Oakville, through a Geotab sensor, see if the truck windshield wipers are on for more than 20 minutes, and we can send an email to the mayor saying it's raining or to somebody else. A system that costs nothing. And this is keeping an open mind, creating open innovation, and having that spirit of collaboration. So I thank you all, and you've seen my name and connection up there. So if there's any more questions, please feel free to reach out to me. Thank you so much.